The sun is the most familiar object in our sky. It rises every morning. It gives us light and warmth. We feel its energy on our skin on a summer day. It helps plants grow and gives life to our planet. For thousands of years, humans have looked up at the sun with wonder. It is a constant presence, a giant glowing ball that seems so simple. But this star, our star, is full of mysteries. It is a place of incredible power and activity. It's actually far more complex and dynamic than it appears from our safe distance here on Earth. We've always wanted to know more about its secrets. For a long time, we could only guess what was happening on the sun's surface. We saw dark spots, which we now call sunspots, move across its face. We knew it was hot, incredibly hot, but the details were hidden from us. The sun's intense light and heat make it very difficult to study up close. It's kind of like trying to look at the filament of the brightest light bulb ever made. Trying to see the fine details is a huge challenge. But science is all about finding new ways to see the unseen. We build bigger and better tools to peel back the layers of the universe. And our own star is one of the biggest puzzles we want to solve. Imagine trying to understand a distant, roaring fire. From far away, you just see a blur of light and feel its heat. You can't see the individual sparks or the way the flames dance and twist. For centuries, this was how we viewed the sun. We knew it was a powerful engine, but the inner workings were a complete mystery. We dreamed of a day when we could see the details of that fire. We wanted to understand the source of its immense energy and the violent eruptions that sometimes burst from its surface. This dream has always pushed astronomers and scientists to innovate and to build new eyes to stare into the heart of the fire. Our curiosity is a powerful force. It drives us to ask big questions. What is the sun made of? How does it create so much energy? What causes the giant explosions called solar flares that we sometimes see? Answering these questions is not just for our own knowledge. The sun has a huge impact on our planet and our technology. Understanding its behavior is crucial for our modern way of life. So, we continue our journey of discovery. We point our most advanced instruments at our star. We are on a quest to finally understand the beautiful, powerful, and mysterious object at the center of our solar system. Recently, scientists achieved something truly remarkable. They captured the deepest, most detailed image of the sun ever taken. It is a stunning achievement, a picture that brings us closer to the sun than we have ever been before. This single image reveals a level of detail that we had only dreamed of seeing. It's not just a photograph. It's a window into the engine room of our star. We can now see features on the sun's surface that are as small as a city on Earth. This is an incredible feat of engineering and science, opening up a whole new chapter in our study of the sun. This groundbreaking image was made possible by a new powerful telescope. It's called the Daniel K. Inouye Solar Telescope, located in Hawaii. This is not just any telescope. It's the largest solar telescope in the world. Its giant mirror, 4 meters across, allows it to collect a huge amount of light. This is the key to seeing fine details from 150 million kilometers away. The telescope also has an advanced cooling system. This system protects its sensitive instruments from the sun's immense heat. It's kind of like having a giant magnifying glass with its own powerful air conditioner, allowing us to stare at the sun without being blinded or melted. Think of it like upgrading your television. For years, we watched the sun in standard definition. We could see the general shape and brightness, but the picture was fuzzy. Then, we got high definition, and the picture became clearer. We could see more texture. This new telescope is like upgrading to a level of clarity that is thousands of times better than anything before. It's like being able to see every single blade of grass in a field from miles away. This new technology allows us to see the sun's surface bubbling and churning in breathtaking detail, revealing secrets that were previously hidden in the blur. The first images from this telescope left scientists speechless. They showed a pattern of turbulent, boiling plasma that covers the entire sun. These cell-like structures, called granules, are each about the size of a country like France. They are the tops of convection cells that carry heat from the inside of the sun to its surface. For the first time, we can see the intricate details within these granules. We can see the hot plasma rising in the bright centers and the cooler plasma sinking along the dark lanes between them. It's a mesmerizing, chaotic dance of incredible power, and we now have a front row seat. With these new, incredibly sharp images, we are learning more about solar flares. Solar flares are gigantic explosions on the sun's surface. They release massive amounts of energy, equivalent to millions of hydrogen bombs exploding at once. For a long time, we knew they were connected to the sun's magnetic fields, but we couldn't see exactly how. The new images show us the small, intricate magnetic structures on the solar surface in stunning detail. We can now see where these explosions begin. It's like finally having a map that shows where a volcano is most likely to erupt, giving us clues about the trigger. The sun's surface is not smooth. It is a tangled web of powerful magnetic fields. These fields are invisible forces, but they control everything that happens on the sun. They twist, stretch, and get tangled up like rubber bands. When these magnetic field lines suddenly snap and reconnect, they release a huge burst of energy. This is what creates a solar flare. The new telescope allows us to see the tiny, bright points within the dark lanes between granules. Scientists believe these points are the footprints of intense magnetic fields, the very places where the energy for flares is stored and then violently released. Imagine watching a pot of water boil. You see bubbles forming and rising to the surface. The new solar images show us something similar, but on a cosmic scale and driven by magnetism. We can see how the churning motion of the sun's plasma twists the magnetic fields. We can observe how these fields get concentrated in the dark gaps between the boiling granules. This detailed view helps us understand the buildup of energy. Scientists can now watch the conditions that lead to a flare in real time. This is a huge step forward in our ability to predict these powerful solar events before they happen. These discoveries are not just pictures, they are data. By studying the movement and brightness of these tiny features, scientists can measure the strength and direction of the magnetic fields. They can create much better models of the sun's magnetic engine. This helps us understand the entire solar cycle, the roughly 11-year period where the sun goes from quiet to very active. Understanding the fundamental physics of how the sun's magnetic field works is the key to unlocking many of its biggest mysteries, from the creation of sunspots to the power source of the solar wind that flows past Earth. You might wonder why we should care so much about explosions happening 150 million kilometers away. The reason is simple. The sun's activity has a direct effect on us here on Earth. Solar flares and another type of solar eruption, called a coronal mass ejection, can send waves of energy and particles hurtling towards our planet. This phenomenon is known as space weather. Just like weather on Earth, space weather can be calm or it can be stormy, and a big solar storm can cause serious problems for our modern, technology-dependent world. This makes studying the sun incredibly important for our daily lives. A powerful solar storm can disrupt our satellites in orbit. This could affect GPS navigation, which we use in our cars and phones. It could interfere with television broadcasts and other communication systems. Solar storms can also create electrical currents in the ground that can damage power grids, potentially causing widespread blackouts. By understanding what causes solar flares, we can get better at predicting them. This would give us time to protect our sensitive technology. We could put satellites into a safe mode or take steps to protect our power grids, much like we prepare for a hurricane on Earth. Beyond the practical reasons, exploring the sun feeds our human curiosity. It is part of our journey to understand our place in the universe. The sun is our closest star, the only one we can study in such detail. What we learn about the sun helps us understand the billions of other stars scattered across the cosmos. It teaches us about the fundamental laws of physics that govern everything, from tiny particles to giant galaxies. Every new image and every new discovery is a piece of a giant cosmic puzzle. It reminds us of how much there is still to learn and how exciting the process of discovery can be. The journey to unveil the sun's deepest secrets is far from over. These new images are just the beginning. They have opened a new door and have already led to more questions. As we continue to stare into the heart of our star, we will undoubtedly uncover even more amazing things. We will learn more about the forces that shape our solar system and make life on Earth possible. This quest inspires a new generation of scientists, engineers, and dreamers. It reminds us to look up, to ask questions, and to marvel at the magnificent fiery star that gives us life.